Today we're looking at ratios and proportions. You will need a calculator. So get your phone, your computer, whatever you need. Unless you can get decimals in your head, I guess. So the first thing is we're looking at the slope, which is the steepness of a line. We describe it as the change in the y values over the change in the x values, or the rise over the run is another way we describe that. We also have a ratio. A slope is really just a ratio. It's the comparison of two values. So we're comparing 3 to 4. So for every 3 pineapples, I have 4 glasses of water. Or another way we write it is as a ratio, so 3 to 4 with the colon, or we can say it 3 to 4. Okay, so 3 different ways to represent a ratio. A proportion is just two ratios that are equal to each other. So for example, the ratio of 2/4, every 2 pineapples I drink 4 glasses of water, we can reduce that down to every 1 pineapple I drink 2 glasses of water. And that's the same proportion. I basically scale down the amount of pineapples I eat, which means that I'm going to also scale down the amount of water I drink. Okay. A unit rate is when we have an amount over 1 unit. So for example, my 2/4. So for every two pineapples, I drink 4 glasses of water. I usually like to reduce this down into a decimal. So I'm going to put in 2 divided by 4. 2 goes in first. It's just a fraction sign, which gives me 0.5. This means that I eat 0.5 pineapples, so half a pineapple, for every 1 glass of water in our pineapple water example. Okay? All right, so we're going to look at a ratio as a slope. So for the rise is associated with the y length of the triangle, and the run is associated with the x length of the triangle. So it looks like this. The rise is the y, so the change in y, and the run is the change in x. Okay, the little triangle thing means change. So let's do example A, and then you guys can do B and C. I have my run. I'm going to start from these 2 good points on my grid. I graph them. I only graph points that are intersecting one of the background lines. Okay, so it has to intersect right at the T. So right here. Okay, so I'm going to count from point to point. So I'm going to count down from the top point. 1, 2, 3, 4. So I'm going down 4 and to the left 1, 2, -2. So when I count, if I count down is negative, to the left is negative, to the right is positive, and up is positive. Since I started from the top point and graph towards the purple point, I'm going to count down and to the left, which is both negative lengths. So the slope of my triangle is -4 over -2, which I can simplify to 2 over 1. So this means that there are 2 units of y in my triangle, or the rise, for every 1 unit of run, which is the y. I switched those. X, sorry, which is the run. Okay, so the unit ratio, I already reduced my fraction. So for every 2 units of rise, I'm changing by 1 unit of run. I'll move my picture on here. Okay, so there would be the unit ratio of the triangle would be 2, just a solid 2, which means that for every 2 units of y, we're moving 1 unit of x. Okay, so the next one, B, I'm going to start from the lower point and move up to the upper point this time. So I'm going to go 1, 2, 3, 4. So my run is 4, and my rise is 1, 2, 3, 4. So rise over run, I do 4 over 4. This time I won't simplify, meaning that there is 4 units of y for every 4 units of x. So every time I move 4 units of x, I'm going to move 4 units of y. My unit ratio, I'm going to divide this in my calculator. 4 over 4, you could do this in your calculator, or you can know that anything divided by itself is equal to 1. So for every 1 unit of y, I move 1 unit of x. Last example that you should try on your own. I personally see that if I count from the bottom point to the top point, I get to count in the positive directions. So 1, 2, 4, and up 1, 2. So the rise is 2 and the run is 4. So for every 2 units of y, so every 2 units in the y direction, I move 4 units in the x direction. Okay? And we can say that the unit ratio, when I divide 2 divided by 4 in my calculator, that is equal to 0.5. So that's technically 0.5 over 1, which means, I'm just going to write it a little smaller. So 0.5 over 1, which means that there's, for every 0.5 unit, so half unit of y, I move 1 unit of x. So let's go check out what that looks like. So if I made smaller slope triangles on line C, I'm going to move over 1 unit of x. And I said if I move over 1 unit of x, I should move up half a unit of y. Ta-da! We're still on the line. Okay, so 1 unit of x, and then we move half a unit of y. 1 unit of x, half a unit of y. 1 unit of x, half a unit of y. We could continue on our merry path drawing smaller slope triangles like that. Okay, so what we're saying is that the larger blue slope triangle here, and the smaller purple slope triangles, they reduce down to the same number, meaning that the slope triangles are equivalent. Even though one is larger and one is smaller, they grow proportionally. So they reduce down to the same number. So what is a proportion? It's when two slope triangles, or when two fractions or ratios are equal to each other. So I'm going to just make a slope triangle on one line A and then one on line B. And then we're going to see if they're the same or if they're different. If they're the same, the slopes are proportional. Here we go. So remember, you got to find points that cross one of the T's. So I'm going to enlarge this a little bit. And I'm going to look. It looks like I have look at this point right there. -4, 0. We cross one of the background lines at a T. What I mean is, look at x equals -6. The line of A does not cross one of the background lines right at the crossroad or the intersection. So we don't like to use those because that's a decimal that I don't really know what the decimal value is. Okay. All right. So I have my point there, and then I'm going to keep going down my line looking for a good intersection. Boom, good intersection. Okay. Go ahead and draw in my slope triangle. So I draw straight down and then straight to the right. Okay, I'm going to move from this top dot to the purple dot. So I'm going to go down 1, 2, 3. Since it's down, I'm going in the negative direction of -3. And to the right, 1, 2, 3, 4. So my rise for triangle A is -3 my run is 4. So for every 3 units I go down, I have to move over 4. So for every unit of, we're going to add, for every unit of y, no, sorry, every unit of x, so we're going to reduce this to negative 0.75. You can just divide that in your calculator. 3 divided by 4, okay, gives me negative 0.75 as a decimal. So for every 1 unit of x, I go down, I can say the rise grows by negative 0.75, which really means it goes down, okay? So it drops by negative 0.75. We're going to graph a slope on the B line. Okay, so I'm looking for a good point of intersection, and I see, I'm going to start from the bottom this time. I see one right here. Okay, so I'm going to graph a point right here, and then I'm going to continue looking. Let's see, I'm going to look for another point. Looks like there's a good point of intersection right here. So you can just choose any 2 points of intersection or any 2 points that cross the grid marks nicely. My hair's kind of crazy. Okay, and then we're going to draw in a slope triangle. It doesn't matter if you draw it above or below the line. So I'm going to go to the right, which is positive, and then down, which is negative. So I'm going to start on the blue dot. I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So the change in x, which is the run, is 8. And 1, 2, 3, 4, 5, 6. The change in y, which is the rise, is negative 6. Let's go ahead and write in our information. So the rise is negative 6. The run, it's a little slow. The run is 8. We'll get the decimal equivalent, which when I divide in my calculator, I get negative 0.75. So for every, which is technically over 1. So for every unit of x, I grow by negative 0.75. So I grow, actually I'm going down. So I'm shrinking by 0.75. All right, next part. So are these two slopes proportional? Proportional, remember, means that the slopes are equal, or the ratios are equal. So even though I use different numbers to set up my slope triangles A and B, they reduce down to the same value, negative 0.75. So we can say that the simplified slopes of A and B are the same. So the slope rates are also, the slope unit rates are the same. This means that the ratios are proportional. So when the two slope triangles reduce down to the same number, your ratios are proportional. They are the same or equal value. All right, you try this one. I have the blue triangle and the yellow triangle. Go for it. Okay, now that you tried, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So the change in x is 8, positive, because we're going to the right. I'm going to count 1, 2, 3, 4, 6. 6 is the change in y. Okay, and we're going to the right and up, which is both positive directions. Okay, so I get the change in y over the change in x is 6 over 8, which reduces down to a positive 0.75. So for every unit of x, we grow by 0.75 units. I'll show you that looks like for every 1 unit of x, I go up 3/4 of a square. 1 unit of x, I go up 3/4 of a square. 1 unit of x, I go up 3/4 of a square. All right, for the yellow, I'm moving over 1, 2, 3, 4. So the change in x is 4. And then I'm moving up 1, 2, 3. So the change in y is 3. When I write my ratio, I write it as 3 over 4, which is 0.75. So the x, for every 1 unit of x, I'm moving over 0.75 units. Notice, if you count the same slope, or the slope on one line, even though you're doing different slope triangles, the ratios are always going to be proportional. So they're always going to reduce down to the same number. We're growing by the same rate. Okay, so the simplified slopes are the same, which means the unit rates are the same, which means that the ratios are proportional. All right, next up, let's go more of this. Okay, red. Find 2 good points on your line that cross nicely on the, wow, this is not a good one. Okay, we're not going to do that one. Just kidding. We're not doing that one. Yeah, sorry. Okay, we're going to do this one. Find 2 good points on your line. I see one right here at negative 5, 2. Okay, so this would be at negative 5, 2. And then another good point at, and we'll call this line A and line B. Oh, I see another good one right here at 5, 6. Okay, draw in your slope triangle. You can draw it above or you can draw it below. So I can draw it up like this, above, making a 90-degree turn right here. Or I can draw it below, making a 90-degree turn. Either way, you're going to come out with we should reduce down to the same answer. Okay, I'll do the slope triangle from above, which gives me 1, 2, 3, 4. So the change in y is equal to 4. And 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The change in x is equal to 10. For the line B, let's find 2 good points. I see I have one right here. Okay. And I'm going to keep following my line. Oh, there's another good point right there. Let's go all the way down to the x-axis. Why not? Okay. So I'm going to draw, this time I'll draw my slope triangle from underneath the line. Okay. So I have the change in y is equal to, and the change in x. So I have 1, 2, 3, 4, 5. The change in x is equal to 5. 1, 2, 3, 4, 5. The change in y is equal to 5. All right, so for the purple, we have 10 is the x and 4 is the y. We always put the y on top, so 4 over 10, which reduces down to 0.4. You can type that into your calculator. 4 divided by 10. 4 divided by 10, okay, gives me, oh, wrong direction, 0.4, 0.4. So technically this is 0.4 over 1, or like a little under a half. So for every 1 unit of x, I move 0.4 units of y, okay? In the blue, I have the change in y over the change in x is 5 over 5, which reduces to 1 over 1. Okay, so for every 1 unit of x, I'm moving 1 unit of y. Oops. So for every unit of x, I need to put an x there. Every unit of x, I move 1 unit of y. Did I write that at the top? Yes. Okay. So this time we look at the slopes. The simplified slopes are different. So the unit rates are different. Okay. This means that the ratios are not proportional. So they are not of equal value. They have different values. They're growing at a different rate. Which one grows faster? Well, this guy goes faster because for every 1 unit of x, I grow by a whole 1. But this triangle A, for every 1 unit of x, I only grow by 0.4. Okay, I'll show you on the graph. I move 1 unit of x and I grow up by 0.4, by 0.4. Whereas on the B line, for every 1 unit of x, I grow one whole block, 1 and 1. Okay, don't forget to do your summary, and that is it for today.